Domain and Range Part 1. In this video, you'll know what is meant by the domain and range of a function. You'll also learn that when given a description of a function in a situation, how to determine a reasonable domain and range for that function. So let's look at domain and range. The domain is a set of all possible inputs of a function, and the range is a set of all possible outputs of a function. So let's look at some examples to try to determine the domain and range for different functions. The function a of s squared represents the area of a square given the side length. Creating a table for a function can help us find the domain and range to find values that make sense for our situation. So in this case, we'll make a table where we're given a side, and then we'll find the area by squaring the side length. So if we have a side length of 1, then we'll also get an area of 1, since 1 times 1 is 1. If we have a side length of 2 and we square it, we'll get an area of 5.25. If we have a side length of 10 and we square it, we'll get an area of 100. And if we have a side length of negative 10, we'll also get 100 when we square it. But negative 10 doesn't make sense in this situation because we can't have a length that is negative or 0. So this tells us that the domain will be all values greater than 0. We can also write this as x is greater than 0. Our range for the function are also all values greater than 0, since any number in our domain squared will also produce numbers greater than 0. And we can also write this as y is greater than 0. Here's another example. A tennis camp charges $40 a day per student. There must be at least 5 students, but no more than 16. R of n shows the revenue the camp makes for the number of students. So we'll make a table of kids and the revenue earned to find the domain and range. The smallest number of kids we can have are 5, and if we multiply the 5 kids times the $40 a day, we'll get a revenue of $200. If we have 10 kids and we multiply it by $40 a day, we'll have a revenue of $400. What if we have 10.5 kids? Well, we can't really have a decimal version of a kid, so decimal values will not make sense for this domain. So our domain will be all integers from 5 to 16. Integers do not include decimal numbers. If we had the maximum number of kids at 16 and we multiplied it by the $40 per day, we would get a revenue of $640. So now we can see our range. Our range would be multiples of 40 between 200 and 640. This example says the cost for a field trip is $30 per student. The function c of x equals 30x represents the total cost based on the number of students, x. We'll make our table again where kids represent the domain and the cost represents the range. If 0 kids go, then it will cost $0. If 1 kid goes, then it would cost $30. And if 3 kids go, then that would cost $90. So our domain is all integers greater than or equal to 0, because we can have 0 kids go, and we had to put integers in there because we can't have fraction or decimal versions of kids. And our range will be multiples of 30 greater than or equal to 0. Our next example says that a rectangle has an area of 24 centimeters squared. Function f gives the length of a rectangle in centimeters when the width is w centimeters. We're going to decide which of these numbers are in the domain of our function. First, let's start by creating a table so we know what the domain and the range are. If we have a width of 6, and we know that the area will always be 24 centimeters squared, then we can just divide our area by the width that we're given. So 24 divided by 6 will give us a length of 4. If we have a width of 2, and we divide 24 by that, we'll get a length of 12. And if we have a width of 0.5, then our length would be 48. So we can see that our domain are all values that are greater than 0, because we can't have negative values or 0 for a length. Our range will also be all values that are greater than 0. So the 3 numbers that match this will be 3, 0.5, and 48. Negative 6 will not be in the domain because it's negative, and 0 can't be a side length. Our last example says to select all possible input-output pairs for the function y is equal to x cubed. So we'll make our table where we'll compare x in the domain and x cubed in the range. If we have an x value of 2 and we cube it, we'll get an output of 8. If our input is -1 and we cube it, we'll get -1 as the output as well, since -1 times -1 times -1 equals -1. And if our input was -1/3 and we cubed it, we would get an output of -1 over 27. So our domain is actually going to be all real numbers, because we saw that positive and negative values work and fractions are okay too. And the range will be all real numbers as well. So all of the coordinates above are all in the domain and range, so we'll just have to make sure that they make sense when they're cubed. We know that -1, -1 is a solution because we did that example in our table. Now let's look at -2, 8. When we cube -2, we should get -8, not +8, so this one is not a solution. Now let's look at 3, 9. When we cube 3, we should get 27, so this is not a solution. Now we have 1/2 and 1/8. When we cube 1/2, we get 1/8, so this is a solution. Now let's look at 4, 64. 4 cubed gives us 64, so this is a solution. Our last one is 1 and -1, but if we cubed 1, we would get a +1 as the answer, not a negative. So this won't be a solution. Now let's recap all that we've learned. The domain of a function is the set of all possible input values. Depending on the situation represented, a function may take all numbers as its input or only a limited set of numbers. And the range of a function is the set of all possible output values. Once we know the domain of a function, we can determine the range that makes sense in the situation.